Print off answer key. Ignore the fact it says Tyler at the top. He had grabbed a copy of this homework instead. The one I told him to grab. Test is going to be very similar to those problems, but it's also going to have pH. I'm going to give you all the formula for pH on the test to use. So pH is equal to the negative log base 10 of the concentration of H plus ions. And this is for some sort of acid. So so has hydrogen and some anion, and it breaks off into its components, where A could be anything. This is for strong acid. Well, this is for any acid. This was what a strong acid would look like. It's 100%. 100% of all the acid molecules, this will be your acid molecule, breaks apart into H plus and your anion, also called the conjugate pair, conjugate acid, acid conjugate, something like that. We also have POH, which is the negative log of the concentration of OH molecules. So we have some base that breaks apart into a cation and anion, and your anion is just hydroxide. But for a weak acid, you need to know this constant, and I'll provide it on the test. H plus, this is for an acid, A minus over HA. This is whenever you have an acid that can go both ways. It doesn't fully disassociate. So a weak acid means not every HA molecule or acid molecule turns into ions. And we have the equivalent, Kb, so I will give you this information on the test. Just need to make sure you know how to use it. So let's do an example of both. Oh, and this information. pH plus POH is equal to 14. So let's do an example. If I do not tell you if an acid is strong or weak, really I should tell you. So just go ahead and assume it's strong. But I'm going to tell you every acid. So everyone good? So let me look up a weak base and a strong base. Let's do lithium hydroxide. LiOH. So what is the pH of 1.5 molar? solution of LiOH. LiOH is a strong base. That means 100% of every molecule is going to dissociate, going to turn into ions. So 1.5 molar, abbreviated as 1.5 M. Molarity, which you should know, is going to, that's the same thing as saying 1.5 moles per 1 liter. So what is the dissociation equation? We have Li going to break apart into Li plus and OH negative. So what is the pH of 1.5 molar solution? So there is no H plus. There is no H in this equation. But we know that pH is equal to 14 minus pOH. Because you take pOH and pH and add them together, it's always 14. So we can calculate the pOH of the equation. That would be equal to the negative log of the concentration of OH negative ions. So we know that we have 1.5 moles per every liter of LiOH. And when it breaks apart, we're going to end up with 1.5 moles per every liter of Li plus ions. And equivalently, 1.5 moles of OH ions. So our concentration of LiOH is 1.5 molar. Our concentration of Li plus is 1.5 molar. And our concentration of OH minus is 1.5 molar. Are the doors unlocked? And this is what we need. We just take this, plug it into the equation. pOH is equal to negative log of 1.5 molar. So you plug that into your fancy calculator. Technically it's log base 10, but log by default is base 10 in most calculators. So that gives me a value of negative 0.1761 all around. And to figure out pH, so I know pH plus pOH is equal to 14. Thus, pH is equal to 14 minus pOH. So 14 minus negative 0.1761 gives me a value of 14.71761. And that'd be my pH. Remember your scale. 7, 14, and 1. This side is basic. This side is acidic. And this is for your pH scale. So 14 over 14 is very, very basic. This is a strong base. You would expect it to be very concentrated. And 1.5 molar is a very strong concentration. Make sense? Let me quickly rush through several more examples. Let's do the pH of calcium hydroxide. And let's make it a half molar concentration. This is also a strong base. So that means 100% of the ions will turn into Ca plus 2 and OH negative. Note, is this balanced? We have 2 OH over here, so we need 2 over here. So I know I have 0.5 moles for every 1 liter here. And this is a 1-to-1 ratio for calcium. So I'll end up with 0.5 moles over here per 1 liter. But how many OH hydroxide ions do I get? For every 1 molecule of calcium hydroxide, I get 2 hydroxide ions. So I end up with 1 mole per liter over here. So that means the concentration of, and these square brackets mean concentration of, is 0.5 molar. The concentration of Ca plus 2 is 0.5 molar. And the concentration of OH negative is 1 molar. I have a ratio of 1 to 2 for that one. This 1 molecule produces 2 hydroxide ions. This is slightly incorrect, I think. Because, let me, I don't know if CaOH negative is a weak base. But I'm going to tell you to assume, unless I otherwise state otherwise, I'm going to assume this is also a strong base. Unless I tell you otherwise, it's in, because what's going to happen is we have this molecule Ca with an oxygen and a hydrogen here, and we have another oxygen and a hydrogen here. What happens is this first hydroxide breaks off. And because this is a strong, 100% of all these molecules will break off. And what we have is this OH negative floating around with, now we have this. The question would be, will this break 100% or not? If it is a strong base, then the problem is simple. We know the ratio. This molecule will always break off and produce 2 of these at 100% ratio. I will clarify that on the test if it's different. So this would mean that the POH is equal to the negative log base 10 of the concentration of OH ions, which would be the negative log base 10 of 1 molar, which would be 0. So POH of 0. So pH would be 14 minus POH. So that'd be 14 minus 0. That gives me a pH of 14. Let's do an example real quick. Everyone good?
Log base 10 set. I guess now that I realize
So, most calculators LOG is by base 10. The other one is LN.
For example, I think it was concentration 0.2 molar on the fog.
So if you type in log of base 100, and if you get an answer of 2, you know it's base 10. Yeah, so Google and Mathematica and Wolfram Alpha, they will assume log is 10 because in science classes we almost always use 10. I'm not 10, they'll assume E, the Euler's number E. So log base E is the same thing as natural log. And E is like 2.73 something. You do have a change of base formula. So if you do natural log of x divided by the natural log of your base, this gives you log of b. I believe that's right. Or basically, if you do log of, I'll say this is base c of x, and you divide it by log base c of b, this gives you log base b of x. Yes. So this is a change base formula. Because the log of 10 log base b of b is always 1. So if you're already at C, whatever base your calculator is using is already B, you're just dividing by 1. So let me find a weak base and show you how to do weak bases. Already done. So ammonium hydroxide is a weak base. So NH4OH, which means it does not 100% convert into NH4 plus and OH negative. This is not 100%. So let me find the KB of NH4. So this KB value for this is 1.8 times 10 to the negative 5. So we know that we don't know this is 1-to-1 ratio anymore. The fact this doesn't go 100%, this could be 1 mole of this turns into 0.001 mole of this and 0.0001 mole of this, which means we end up with a leftover of 0.99999 moles of NH4OH. Does that make sense? So if this is a weak base, only a small percentage of it actually converts into ions, while most of it stays as molecules. Not everything dissociates in water. But we have a constant for it. Kb is thus going to be equal to the concentration of NH4 plus and OH negative ion divided by the concentration of NH4OH. And let's suppose we started out with 0.25 molar solution. So this right here, this initial solution, tells me that the concentration of NH4OH is equal to 0.25 molar. And I know my Kb is equal to 1.8 times 10 to the negative 5. This is where the ice method comes into play. I'm going to assume that I'm going to start out. So let me do this. We have NH4OH is converting partially into NH4 plus and OH negative. This one doesn't really recall for ice. I'm going to assume I'm going to start out with a concentration of 0.5 molar, and none of it has converted into ions yet. We're going to lose some X amount of ions, molecules, and we're going to get some X amount of molecules here. So my final concentration at equilibrium is going to be 0.25 minus X and X here. So this was what I initially had. This is my initial condition, I should say. My final at equilibrium, my concentration of NH4 plus is going to be X. My concentration of OH negative is going to be X. And my concentration after reaching equilibrium is going to be 0.25 minus X. And you can approximate by asking yourself, is 1.8 times 10 to the negative 5 significantly less than 0.25? This is 4 orders of magnitude, which means 0.25 minus X is approximately equal to 0.25. I'm probably only going to ask this as a bonus, as just how time consuming it is. I will tell you on the test if I do give a problem like this, you can make this approximation. I will tell you that you can use approximation method, which means that this can be approximated with this. So plugging it into our equation, Kb is equal to X times X minus 0.25 minus X. And Kb is 1.8 times 10 to the negative 5. So you can solve this mathematically. If you approximate, that's X squared divided by 0.5 here. And then just solve for X. So multiplying that across, that is 4.5 times 10 to the negative 6 is equal to X squared. Taking the square root of both sides, I get X is equal to 0.00212,132. And our X represents the concentration of OH ions, or POH, or I should say, or pH, would thus be 14 minus the negative log of 0.00212,132. That is 14 minus pOH. And this is pOH. Did I confuse anyone? I get a pH of 11.326, which is basic, not too strongly basic. That makes sense? Let's do another one. So the one I did in class earlier was sulfuric acid. Let's make this a 2 molar solution. Sulfuric acid is a strong acid. However, HSO4 ion is a weak acid. So H2SO4 will 100% turn into H plus and HSO4 ions. Oh, and we can calculate this. So we have 2 molar here, which means 1-to-1 ratio. We get 2 molar of this and 2 molar of this. So 2 moles per every liter, 2 moles per every liter. So 1-to-1 and 1-to-1 ratio. But H2SO4 negative is a weak acid. It does not 100% break apart. So we're starting out with 2 moles of this per liter. That'd be your I. We're starting out with 2 moles per liter of H plus from the original acid. And this is assuming right before we actually start breaking this apart. So our change is we're going to break apart some X amount of this. And it'll give us X of this, 1-to-1 ratio. And thus our equilibrium point would be 2 minus X, 2 plus X, and X here. So our Ka is equal to the concentration of H plus with our concentration of SO4 negative 2 divided with our concentration of HSO4 negative ions. Looking up, we have HSO4 negative Ka value. Where's it at? So that's hydrogen sulfate. There it is. It is Ka of it is 1.02 times negative 7. So that would be 1.02 times negative 7. This would be our final concentration of H plus, which would be 2 plus X. Our concentration here is X. And our concentration of HSO4 negative is this one right here, 2 minus X. And then just solve for X. So moving this to the other side, we have 1.02 times 10 to the negative 7 times 2.2 minus x, and that'd be equal, distribute that'd be 2x plus x squared. So that would be 2.04 times 10 to the negative 7 minus 1.02 times 10 to the negative 7. X is equal to 2x plus x squared. Move that to the same side, do your quadratic formula, which I'll give y'all the quadratic formula too on the bonus problem. I will tell you the bonus problem is going to be like this. I'm going to give you a bonus problem where you have to go through and do this. I'll give you the quadratic formula. You have to solve for it exactly. I've already solved this for one version of it, but this is just solving for x with the quadratic formula. Move everything to one side. You have the coefficients. Then solve for, plug it in the coefficients into the quadratic formula. So on the test, I'm only going to do mainly pH of strong acids and strong bases. I think I will have one weak acid, but it will be a weak acid where you don't have to chain it. It's complicated when you chain it, and I will make it to where you can approximate it. So I'll tell you that you can approximate it as the Ki is too small or very small, in which case you could do something like this. But the majority of the test is going to be like this. Figuring out concentrations. And it's going to be multi-step too. So, for example, you have 100 milliliters of 0.5 molar lithium hydroxide. And you mix it with, or neutralize it with 50 milliliters of hyposulfurous acid. What's the equation? We have LiOH reacting with, well, OUS is height. Hypo is hypo, so this is hyposulfate. SO4 negative 2 is sulfate, or I mean, this is hyposulfite. So ite and a hypo means remove 2 oxygen, so that's SO2 negative 2. And we have an H plus, so that would be H2SO2. And this makes the H with OH is water, and the Li with the SO2. We need to double this. 3 oxygens. We need to double this. How many moles of lithium hydroxide do we have? Again, what do we know about lithium hydroxide? We know we have 100 milliliters, and we have 0.5 molarity of it. These are the 2 things I know about lithium hydroxide. So I have 100 milliliters of lithium hydroxide. And now do conversion factors, dimensional analysis until we get our answer. We're looking for moles. So go ahead and convert into liters. I know 1,000 milliliters of lithium hydroxide is equal to 1 liter of lithium hydroxide. So milliliters and milliliters cancel out. I know molarity is 0.5 mole of lithium hydroxide per 1 liter of lithium hydroxide. Thus, liters of lithium hydroxide left cross out. And the only unit I have left is moles of lithium hydroxide, so that is our answer. Dimensional analysis, as long as you keep track of the correct value and dimensions of everything, it will always get you to the correct answer. I did notice on some of y'all's homeworks, y'all chose wrong ones. For example, someone started with 50 milliliters. 50 milliliters is attached to the hyposulfurous acid. You should keep the full unit for it. This is milliliters of lithium hydroxide. How many moles of hyposulfurous acid do we have? Well, I know I have 50 milliliters of it. This equation gives me a conversion ratio right here. It is 2 moles of lithium hydroxide, or 2 molecules. We can increase that number for every 1 mole of H2SO4. Which this does nothing for me. I cancel out these two. I can't cancel it. Milliliters and mole H2S don't cancel out. This is why dimensional analysis is very useful. If you make a mistake, it's very helpful. You always start with something you know that you can plug in. So try again. Let's do 0.05 mole. Again, I know a ratio, so let's continue this right here. I have 2 mole of lithium hydroxide per 1 mole of H2SO4. That works. Mole lithium hydroxide cancels out here, and now I have mole of hyposulfurous acid, which is what I'm wanting. So I just divide that number by 2, 0.025 mole. If you make a mistake, and as long as you keep your units, you can see spot your mistake. They don't cancel out, and you can then correct for it. Choose another starting value that you do know. Now, what is the concentration of sulfuric acid or hyposulfurous acid we use? Well, I know I have 50 milliliters, and I know I have moles. Concentration in this class, the best unit for concentration is molarity, which is moles over liters. So take your moles, 0.025 mole, and divide it by something you can convert into liters, which you're given the 50 milliliters. Of H2SO4. You need to convert that into liters. That should be 2. So milliliters cancel out. So that is equal to 0.5 molar. Make sense? So, a lot of questions like this. Make sure you get down. I'm going to have a few questions on pH and pOH. Tomorrow. Yeah, I know. Y'all just have to make it up whenever you get back. Star testing all next week. I wanted to do this unit before the star test instead of after all the star tests, but y'all can. Don't know which days I'm giving star tests. I want to say I'm giving it on Tuesday and Wednesday. I'm not for sure on Monday when I'm doing. Yeah, you can always come after school. I will give you this information too. Weight percent is going to be percentage is a ratio of mass of solute divided by volume is W/V of solution, where your mass is in grams and your solute is in milliliters. W/W is going to be your grams per grams, the gram solute per grams solution. And your volume per volume is milliliters per milliliters. A milliliter solute per volume solution. And it's dimensional analysis. So, and molar mass. There is going to be a lot of molar mass is needed. There'll be questions like how many grams. There'll be also a lot of questions, how many grams do you need to add to make a 0.1 molar solution? Or 100 milliliters. 0.1 molar solution of something. So let's do like NOH. So we want 0.1 moles per 1 liter. That's our concentration. And we have 1 liter divided by 1,000 milliliters. And I'm that tells us we need 0.1 mole per 1 liter. Running out of time. That gives us how many moles per milliliter we need. And then you put molar mass in here. Molar mass tells you how many grams per mole, where the moles will cancel out here. And this will tell you need how many grams per 100 milliliters. You would also need to add in, to get rid of milliliters, you need to put in the 100 milliliters right here. Cancel out milliliters. Your final answer would thus be how many grams you need for that 100 milliliters. Make sense? I'm thinking one blank piece of paper of notes. Front and back. So one notebook paper. You can write one notebook paper worth of notes, front and back, and use it on the test.
Yeah. Yeah, we get
Any questions about the test? Haven't made it yet. I know exactly what questions I want on the test. The issue is timing. I don't know, so I'm going to take the test myself, time myself, and my rate, my thing I've always used that's been very accurate is if the class period is 50 minutes long, I can do the test slowly in 25 minutes. That usually indicates the students have plenty of time to do it. And by slowly, I mean writing out all the notes and not doing any shortcuts. If I can write out all the work and complete a test in half the time with all the steps shown out without doing any shortcuts, that usually means every student is fully capable. Because I've done tests where I've done that, where it took me 25 minutes and I've had students turn it back in with an A in 10 minutes. Because they don't have to show all their work, they can just look at it and go, there's the answer. Like, for example, whenever I plug in the 1 mole to 2 moles, y'all usually just look at it and be like, multiply it by 2 in your head.